Hi, welcome to my new demo. Today I would like to show you the dynamic resource allocation in structured streaming. So I will run this demo on top of Kubernetes and I will execute this very sample code using the rate stream. And as you can see, I will create 10 input partitions and generate 20 rows per second. What will happen is that whenever the modulo result for this division is equal to 0, I will sleep the task for 1 minute so that the Apache Spark dynamic resource allocation can create new executors to handle the remaining pending tasks. So as I said in this demo, I will use Kubernetes and I will simulate it with Minikube. So I started it already with the dashboard. The next step will be to build my application. So I will run the maven clean install. And in the meantime, I will create all required resources. So I will just set the current namespace. I will create a Spark editor service account so that the driver can create the executors. Okay, and now I'm already in good directory, and I will also change some configuration properties in the log4j. Yeah, so that I will see everything in debug mode. Next thing is to build the image. So my Docker image uses data mechanics pre-built Spark image, and I will simply copy my jar to this opt application directory. So let me build the image first. Once it's done, I will create an archive that I will upload to the Minikube, and later I will start my Apache Spark job, and we will see together what happens if one task gets stuck for too long. It won't be any surprise for you if you use the dynamic resource allocation with batch jobs, because the underlying algorithm is exactly the same for structured streaming jobs. So let's wait it to terminate. Okay, Minikube image load, and now I will also check whether the load was successful by listing all the images available on Minikube. Of course, on the cloud you can use container registries services for that. Yes, we have a Spark structured auto scaling. That's great. Now I also need to check the master. The master is this port, so just for some simplicity I will export it as a variable, and now I will start the job. Okay, it's starting. Let's see now what happens in my auto scaling namespace. So we are started with a single executor because it was the content of the Spark submit command. However, you will see that very soon we will start to create a different executor, because this first one will get stuck with our modulo division 1 minute sleep. So just let's wait a while. Yes, you can see that we created the second executor, and just maybe we will focus a bit on the command that I executed. So I didn't introduce it before, but the scheduler backlog timeout is 15 seconds and the executor idle timeout is of 2 minutes, meaning that whenever the tasks are stay unscheduled for at least 15 seconds, we'll try to schedule them by creating new executors, and whenever an executor doesn't have anything to do for 2 minutes, we will take to remove it from the cluster. So that was for this feature, and now I will show you what happened by analyzing the log. So we have a pretty a lot executors right now, but let's not focus on that here. Just see what happened with this execution.